Introduction to TensorFlow and Data Analysis. In this tutorial, we aim to explore how to leverage TensorFlow, not just for machine learning but specifically for data analysis. By the end, you'll know how to load data, pre-process it, and perform some basic analysis. Let's start by installing TensorFlow and its dependencies. Make sure you have Python installed, ideally version 3.7 or later. Once TensorFlow is installed, let's import the necessary libraries for our analysis. We'll be looking into NumPy and Pandas as well for data manipulation and analysis. Now, let's load a dataset to work with. For this tutorial, we'll use the famous iris dataset, which is a classic in data analysis. The dataset contains measurements of different species of iris flowers. Next, let's take a look at the first few rows of the dataset to understand its structure. This will help us decide on the analysis methods to employ. The output shows us that our dataset has 5 columns, comprising 4 feature measurements and 1 target species label. Analyzing this data further requires some pre-processing steps. Let's check for any null values. We can see that there are no null values in our dataset. Now, we'll proceed to encode our categorical species variable into numerical values, which is necessary for any numerical analysis. Our data is now ready for analysis. Next, we can normalize our feature measurements. Normalizing is crucial as it ensures that all features contribute equally to the analysis. We'll use TensorFlow's pre-processing tools for this. Now that our features are normalized, we can visualize our data. Visualization helps in understanding the distribution and relationship of the features, which is essential for effective analysis. From the scatter plot, we can see some distinct clusters that may help us distinguish between the different species. To confirm if the features contribute significantly to our analysis, we can compute a correlation matrix. The correlation matrix will give you a sense of how strongly each feature is related to another. High correlation values, near 1 or -1, suggest a strong relationship. We can also visualize this using a heat map. With our visualizations and correlations, we can conclude that there are significant relationships among features, which can be vital for any further machine learning tasks. Next up, let's explore TensorFlow's capabilities in handling data analysis through linear regression using our dataset. Now that we have our training and testing sets, let's build a simple linear regression model using TensorFlow. We'll define an input layer, a single hidden layer, and an output layer. With our model defined, we can now proceed to fit our model to the training data. This is where the model learns the relationships within the data for accurate predictions. As the model trains, it will output the loss and accuracy metrics for both the training and validation datasets. Higher accuracy signifies that our model is learning effectively. After training, let's evaluate the model's performance. This evaluation will provide us with the accuracy of our model on the unseen test data. A score greater than 0.8 is generally considered good for simple datasets such as iris. Finally, let's visualize the model's predictions against the actual labels. In the scatter plot above, we can see how well our model predicts the labels. Ideally, the points should cluster along the diagonal line indicating accurate predictions. If you notice large deviations, it may suggest areas for improvement such as feature engineering. To summarize, we've covered the process of loading data, pre-processing it, visualizing relationships, and finally applying TensorFlow for modeling. This tutorial offered a comprehensive introduction to utilizing TensorFlow for data analysis.